Test, test, test. Hello, and welcome to this video for Physics 132 on the idea of magnification. Now this video assumes that you've already watched the videos on the introduction to lenses, an introduction to mirrors, and the terminology associated with images. If you have not watched those videos yet, go watch them now. By the end of this video, you should be able to define magnification and describe, based upon object and image heights, when the magnification is greater than 1, less than 1, or equal to 1. And finally, given object and image heights, you should be able to calculate the magnification. The basic idea of magnification is that when you have a collection of lenses and or mirrors producing an image, that image may be larger or smaller or the same size as your original object. To use our two examples from the terminology of images video of the eye and the makeup mirror, we can see that the object in both cases is once again the person. However, in the makeup mirror, we get an erect image. The image is right side up, which is larger than the object. That's the whole point of these particular types of mirrors, so that makes things bigger so you can see what you're doing. On the flip side, the image on your retina is much smaller than your object. I mean, a person is about 1.5 meters tall, and a 1.5 meter image clearly won't fit on the back of your eye. How do you calculate magnification? The magnification of an image is the height of the image, hi, relative to the height of the object, ho. So just this simple ratio. Images that are larger than their objects will have a magnification which has a magnitude greater than 1, while images that are smaller than their objects will have a magnification with absolute value less than 1. Now, as with everything else in optics, there's a sign convention. By convention, the original object's height is always positive. Ho is always greater than 0. For the image, on the other hand, if the image is erect, the image height is positive, whereas if the image is inverted, the image height is negative. Let's do two qualitative examples using the eye and the makeup mirror we've been talking about thus far. So for the eye, the image is inverted, so we can say that the image height, hi, is negative, which means that since the object height is always by construction positive, the magnification will also be negative. Furthermore, the image is smaller than the person, which means the magnification is somewhere between 0 and -1. Now to turn to the makeup mirror, the image is erect, so we can say that the image height, hi, is positive, implying that the magnification is also positive. And the whole point of these makeup and shaving mirrors is to make things bigger, so we can say that hi is bigger than ho, which means the magnification is going to be bigger than 1. Now let's do a short quantitative example. A microscope makes a 10 centimeter upside down image of a 1 micrometer bacterium. What is the magnification of this particular microscope? Now, I always need to convert to the same units. It doesn't matter what units they are, but hi and ho need to be in the same units. So the image is in centimeters. It's 10 centimeters. So I'm going to convert the object height, 1 micrometer, into centimeters. 1 micrometer is 10 to the minus 4 centimeters. Now, the image is inverted, so the image height's not actually 10, it's minus 10 centimeters. Now we have all the information we need to go and calculate the magnification. The magnification is the image height over the object height, and the image height is minus 10 centimeters, and the object height is positive 10 to the minus 4 centimeters. Remember, object heights are always by convention positive. Doing the ratio, we can see that m is going to be minus 10 to the positive 4, or minus 10,000. So the magnification is negative 10,000 times. Note that magnifications, since they're a ratio of two things with the same units, in this case centimeters over centimeters, are in fact unitless. So in summary, the magnification looks at the ratio of the image height to the object height. And the object height is always defined to be positive by convention. The image height, on the other hand, is positive if the image is erect, or negative if the image is converted. This concludes this video.